module, let us look at an example problem and understand plotting and modification of signals. So in this problem, the given signal x of t is defined as follows. It is 1 minus 2 mod t for mod t less than or equal to 1, and it is 0 otherwise. So what we need to do over here is, first we need to plot x of t using the given definition, and then by applying suitable operations on x of t, we need to plot x of 4 minus t. Okay. So before getting started, let's just have a look at few operations and tools which will be very useful for solving such kind of problems. Okay, so now let's look at a set of properties. The first of which is the time shifting property. In this property, the signal x of t is getting modified to x of t minus a, where this a is any positive or negative constant. Now if a is greater than 0, that is if a is positive, then x of t minus a will be a delayed version of x of t, and if a is less than 0, then x of t minus a will be an advanced version of x of t. Now let's understand this time shifting property by solving an example. So consider this given signal x of t, which is shown as follows, and now we have to plot x of t minus 2. Now the way we need to solve this is by equating the inner coefficient to 0, that is by equating t minus 2 to 0, we get t is equal to 2. Now we have obtained a positive value of t. That means that the signal is going to shift towards the positive half of the t-axis, that is it is going to shift towards the right side. Why? Because the value obtained by equating the inner coefficient to 0 is positive. That's why the signal is going to shift towards the right side, towards the positive half of the t-axis. So let's just shift the given signal towards the right side by 2 units, since this is 2. So the signal will look something like this, where this is 0 and this is 0, and this will also get shifted by 2 units, so this will be 2. Now let's plot x of t plus 2. So equating the inner coefficient to 0, we get t is equal to minus 2. Now this negative sign indicates that the signal is going to shift towards the negative side of the t-axis, that is it is going to shift towards the left side by 2 units. So let's just plot this. Now it will look something like this, where this is now minus 4, since it has been shifted by 2 units towards the left side. Earlier it was minus 2. By shifting more 2 units over to the left side, it has become minus 4, and this thing is minus 2, and this is the origin. Okay, so this was the time shifting property. The next property we are going to look at is the time scaling property. In this property, the signal x of t is being modified as x of at, where a is any positive constant. If mod of a is greater than 1, then x of at will be a compressed version of x of t, and if mod a is less than 1, then x of at will be an expanded version of x of t. Now let's understand this by looking at an example. So let's just consider the given signal x of t, this triangular shaped signal, and let's try to plot x of 2t. By comparing this with x of at, a is equal to 2 and 2 is definitely greater than 1. So the signal we are going to get over here is going to be a compressed version of the initial signal x of t. So what we need to do over here is, we need to take the reciprocal of a, and then we need to multiply it to each and every time instant in the t-axis. So by multiplying 1 over a, that is 1 by 2 in this case, to each and every instant, we can obtain this signal. Something like this, where this is minus 1, 0, 1. And similarly, if we try and plot x of t by 2, in this case a by comparing is 1 by 2, that is 0.5, which is less than 1. Hence now the reciprocal of a, that is 1 by 1 by 2, 1 by 1 by 2 is 2. Now we need to multiply 2 to each and every instant in the time axis, t axis. So now the signal will be something of this type, where this is -4, this is 0, and this is +4. Time scaling property can also be understood as follows. Let's just consider x of t. If x of t was an audio tape, then x of 2t will be the audio tape played at twice the speed, and x of t by 2 will be the same audio tape placed at half the speed. Now generally, if an audio tape is being played at twice the speed, obviously its duration will decrease, and if it's being played at half the speed, then obviously its duration, its width will increase, and it can be clearly seen from the given example. Now let's look at the next property, that is time reversal property. In the previous property, time scaling property, x of t was being modded to x of at, but a was only any positive constant there. Now by just substituting a is equal to -1, we get the time reversal property. According to the time reversal property, x of t, any signal x of t, is going to be changed as x of -t. Now what happens here is, whenever we apply time reversal property to any signal, the signal which is present in the positive half of the time t axis gets interchanged with the signal which is present in the negative half of the time axis. That is, positive becomes negative half and the negative half becomes the positive half. This can simply be obtained by rotating the signal about the vertical axis, that is about x of t axis. Just by rotating this, the positive half will become the negative half and the negative half will become the positive half. So now let's just plot x of -t for the given x of t, which will look something like this. This is x of -t, and then this is -4, and this will become -2, this will be 0, this will become 1, and yeah, that's it. The next property is known as the amplitude scaling property. According to this property, in this property, x of t is being modified to a times x of t, where a is any positive constant. This is similar to the time scaling property, and this is a bit easier. All we need to do is, we just need to multiply the constant a to the amplitude of the given signal. Let's just understand this by an example. Let's try and plot x of 2t, sorry, the x 2 times x of t, and let's plot half times x of t as well. So if you just try and do this, all you will get is, you will get something like this in this case, and you will get something like this here, where this is 2 the amplitude and this amplitude is now half. Okay. The fifth property is known as the amplitude reversal property. This is quite similar to the time reversal property. In time reversal property, what we've seen is the positive and negative halves of the time axis get interchanged. The amplitude reversal property is quite similar, except instead of the t axis, the amplitude axis, the x of t axis, gets interchanged. So to obtain this, what we can do is, we can just rotate the signal about the t axis such that the positive half and the negative half of the amplitude gets interchanged. So for the following example, let's try and apply amplitude reversal. So we will get something like this. This will be your minus x of t. Okay, an important note here: any operation on time of signal will not have any effect on amplitude of signal, and vice versa. So this means that if I perform time shifting or time scaling or time reversal on any signal, that will not have any effect on the amplitude of the signal. And if I perform amplitude shifting or amplitude scaling, if I perform amplitude scaling or amplitude reversal on any signal, that will not have any effect on the time axis of the signal. Like in this case, we have performed amplitude reversal, but still the time instants will remain same, that is -2, -1, 0 and 1 and 2. And even if we look at the previous properties, we had performed like in this property we had performed time scaling, only the time axis, only the width was being changed in all the three examples. But if we observe carefully, the amplitude of the signal has remained constant. So that is an important note. Okay. Now if we just summarize the three properties altogether, in time shifting property, x of t will be x of t will be changed to x of t minus a in the time shifting property. In the time scaling property, x of t will be changed to x of at, and time reversal property, x of t will become x of minus t, and in amplitude scaling we will multiply by constant outside, and in amplitude reversal property, x of t will become minus x of t. Okay. Now we have looked at a few operations on signals. Now let's look at a few basic plotting tools which will help us to plot any given signal. Now we know that if we have any line, let's say the coordinates of this line, of one end of this line are x1 comma y1, and the coordinates of the other end of this line are x2 comma y2, then the equation of this line is given as y minus y1 is equal to the slope of the line, that is y2 minus y1 by x2 minus x1 times x minus x1, right? But this might be a bit lengthy, so another way, a shortcut to write the equation of the line is just by observing the line. If this line cuts the x-axis, let's say this is the x-axis and this is the y-axis, if this line cuts the x-axis at a units from the origin, and the same line cuts the y-axis at b units from the origin, then this line, the equation of this line can be represented as x by a plus y by b is equal to 1. You can also do it the other way around. If you are given the equation, you can find the sketch of the line. That is, the given equation should be written in the form of x by a plus y by b is equal to 1. Then by equating the coefficient of x, we can get a, and then by equating the coefficient of y, we can get b. And then what we need to do is, suppose by equating we get x equal to minus 5 for example, and we get b is equal to 3, then what we need to do is, on the coordinate system we need to plot a is equal to minus 5, and then we need to plot b is equal to 3, and then to obtain the plot of the line we need to just join the 2 points. Okay. Now let's look at another interesting function, the interpretation of which is very essential for us to solve the given problem. The function is f of x is equal to mod x. Now simply, if you define this function, we know that the modulus of any positive number is a positive number only, but the modulus of a negative number is a positive number. You just remove the negative sign and you just take the number, the positive number. So if you represent this mathematically, how you can do it is, mod x takes two values. It takes one value when x is greater than 0, and it takes another value when x is less than 0. That is it takes the value x when it is greater than 0, and it is treated as minus x when it is less than 0. How? If you need to understand this in detail, let's look at a few examples. Let us consider x is equal to let's say a positive number 2. So mod x, since this number is positive, this rule will be applied. This will be x only, which is equal to 2. Hence we've got mod x equal to 2. And let's consider another example where x is equal to minus 3. Then modulus of x will be given as minus of minus x. Since minus 3 is less than 0, so this rule should be applied. It should be taken as minus x. So minus of minus 3 is plus 3. Hence this was the mathematical representation of the given signal. Okay. Let's just look at this again. It might be a bit confusing, but it's definitely interesting. If mod x, that is, if the value of x inside is greater than 0, then the function should be taken as x itself. Actually, this mod x is defined at two different instants, unlike simple functions which are defined as just a single function. At x is greater than 0, at the positive half side of the x-axis, it should be taken as x, and in the negative half, because the value of x inside is negative, it is multiplied by a minus sign so as to remove the minus sign. Now if you happen to encounter, if you find an equation which you need to solve which involves this mod x function, all you need to do is you need to have clearly defined intervals at which x is clearly positive and x is clearly negative. So in the interval in which x is positive, that is x is greater than 0, mod x should be replaced by, just replace mod x by x and proceed to solve the equation. And if x is less than 0, that is if x is negative, replace mod x by minus x, and then whatever you need to do, if you need to plot the equation or you need to solve it, you can solve it. Just remember, if you need to have two clearly defined intervals in which x is positive and in which x is negative, and in the positive interval mod x should be replaced by x, and in the negative interval mod x should be replaced by minus x, and the reason has been given above. Now let's look at one more interesting property related to this modulus function. This mod function can be also used to define intervals. So let's look at this. Let's say look at this question which says plot the interval of given by mod x less than or equal to 3. Now we know that, let's just plot a number line. Let's say this is the number line and these are the time instants, x instants, sorry, this is the x-axis, right? We are using x right now. So let's say this is the number line and I'm writing the time instants, and the number line is stretching till infinity, minus infinity and plus infinity. So now in the positive half of the x-axis, that is from the right side of the origin, mod x can be rewritten as x, as we've seen above just now. In the positive half, this interval is being redefined as mod x less than or equal to 3. So if we plot this interval, now this is pretty simple, it is this interval, right? And now when x is negative, mod x can be replaced by minus x less than or equal to 3, and if we multiply by minus sign on both sides, the equality reverses and we get x greater than or equal to minus 3. So now that is defined by this interval. So combining both the intervals, mod x less than or equal to 3 can also be rewritten as follows: minus 3 less than or equal to x less than or equal to 3. And if any other number other than 3 is given over here, that number will come over here. I hope you've understood this. Now let's look at another representation of an interval using mod x. So now consider the interval mod x greater than or equal to 2. So now clearly, when x is positive, on the right side of the origin, x greater than or equal to 2, mod x will be replaced by x, and on the negative half, mod x will be replaced by minus x greater than or equal to 2, which implies x is less than or equal to minus 2. And if you try and plot this, if you just represent this, show this on the number line, this is 0, 1, 2, 3, and this is -1, -2, and -3. And so on the right side, that is this, when x is positive, it will lie between 2 and infinity, till it can lie anywhere between 2 and infinity. And when it is negative, when x is negative, according to this equation, it can lie anywhere between -infinity and 2. So according to this interval, x, the value of x can lie anywhere except in the range of -2 and +2. Apart from this range, the value of x can lie anywhere. That is, excluding this interval, mod x greater than or equal to 2 is the entire number line except this interval, excluding this interval. Okay. Now let's look at one last denotion, that is, let's denote the interval given by 2 less than or equal to mod x less than or equal to 4. Now let's plot the number line again and just write this once more. This is 0, 1, 2, 3, 4, and 5, so on up to infinity, -1, -2, -3, -4, and -5, so on up to infinity. So similarly, repeating the procedure on the positive side, on the right side, mod x can be replaced by x. So when x is positive, the interval becomes this one, and when x is negative, the interval becomes 2 less than or equal to -x less than or equal to 4, multiplying by minus sign throughout. This becomes -2 greater than or equal to x greater than or equal to 4. So now if you plot this one, you will get the interval lying between 2 and 4, and if you plot this one, you will get the interval lying between -2 and -4. So I hope now this is also clear to you. Now, so far in this video, we have seen various operations that can be performed on signal, and namely the time shifting property, the time scaling property, the time reversal property, the amplitude scaling property, and the amplitude reversal property. Now I hope all of us are in a position to solve the example problem given at the start of this video. Hopefully all of us can solve it, and this is it for this video, and we'll look at the solution of the problem in the next video. Till then, take care, and thank you for watching this video.